Okej, har du några funderingar över hur mycket jobb man lägger ner på en snöskotermotor innan den kommer i produktion? Ska du titta på det här programmet. Programmet presenteras av RG3 Suspension, Motorsnack, Svedea snöskoterförsäkringar, norrländsk skadehantering och Sveriges nöjdaste kunder 5 år i rad. Ja, det här med att tillverka en snöskotermotor, det är inte bara att vara. Det tar ju sin lilla tid sådär från idé till färdig produkt. Därför så har vi gått lite till botten med den här och haffat tag i en av Polaris absoluta toppgubbar inom motortillverkning och framförallt de här från idé till färdig produkt. Då. Vi klipper väl dit.
Okay, let's start. You can introduce yourself.
So my name is Dallas Blake. I'm a senior staff engineer on powertrain. I work exclusively on two-stroke engines. I've been with Polaris about just over 14 years. I'll be 15 this coming December.
Okay, so you're one of the guys behind every two-stroke engines that's available today.
Yep, we have a whole team that works on it. I've been working on two-strokes essentially all my life. I started with Polaris in 2009, and the first project that I worked on that came to production was the 800HO engine.
Okay.
So we went through a lot of development work on that. That started around 2012 timeframe. And generally when we're developing these engines or new architectures, we work through a number of different features or functions that we want to implement into it. So we test a number of different things independently of each other. So when we did the 800HO, first thing we did is we started to understand the benefit in fuel economy and torque that controlling the exhaust subports would do. So we actually had special cylinders made up that had no subports in it, just as a test to see what benefit we would get for that. And then as we go into Patriot, right, we knew where the limitations on our 800 architecture, which was based on the old 440 small block Liberty engine. So it was a little bit long in the tooth. We know we needed something new, so we went and tried to understand where all of our biggest shortfalls are, where we really wanted to push the market, and what improvements we wanted to make. So when you do something like that, you have a clean sheet, you try to understand what the best configuration is. And with Polaris, our main focus is the ride experience and how it feels on the vehicle. So you can make the absolute best engine on the dyno, but if it doesn't work in the snowmobile, it's pointless.
Okay.
So on Patriot, we actually built 3 different concepts with different bore and stroke configurations.
Okay.
We made an 800 version, we made an 840 version, we made a 144cc version. And we actually took them all out to Togedy and rode them with all of our senior leadership and all of our development team to get them on each of the sleds and say, which one do you feel best represents our product?
Okay. So when you make a prototype engine, you don't use any like cast parts. Is it all billet and then machine parts? They have like a special department who makes this part, because I think it must be like a really expensive process to cast things just for a prototype.
It depends on the parts. Like if we're making brand new engines, we'll usually do billet crankcases.
Yeah.
And we'll do proto tooled stators, flywheels. We'll do one-off crank forgings. But when it comes to pistons and cylinders, we have really good suppliers that we work with that will make single cavity tools.
Oh, okay.
Right, we'll make it so that we can just produce a small batch of parts.
Oh, okay.
And we'll do 3D printed cores for the exhaust, 3D printed cores for the entirety of the cylinder.
Metal parts, also metal 3D printed parts.
Well, there'll be 3D printed sand cores.
Okay.
And they're cast.
Oh, I understand. Okay.
Yeah. So it goes through all of our same production process. It's just, it's a faster way to do it. It's not conducive for large volume production, but it works very well if you only want to make 20 pieces.
Okay. So to make an engine that lasts and give and make much horsepower, that's not the the problem of it, because you have like other things to think about too, like fuel consumption and exhaust, what comes out in the exhaust.
Yeah, the challenge with two-strokes now is that they're getting the customer ask of two-strokes is becoming very, very tough, right? So we need low-speed drivability, we need refinement, we need acceleration, we need high-end power, we need durability, and then also we need to comply with regulatory requirements, which includes exhaust emissions and sound output. Right, so those are important things that we drive, but when we go into a new program, we try to set our benchmarks for where we want that to be. Right, so A50, it was about durability, it was about performance, and it was about trying to improve the low-speed operation and refinement of the vehicle. Right, that's why we developed the new mounting system, because it translates less vibration to the ride.
Okay. Yeah. So if you had no regulation and no restrictions regarding sound and emissions and everything, how much do you think, like in 850, if you could build an engine, however you would, 2 cylinders, 2-stroke, like 850 cubic, and then how much horsepower do you think you can build an engine that's quite reliable? So
you could definitely make a little bit more power out of it. It wouldn't be this huge jump, because the limiting factor in power is really how stable the engine is. So how wide the fueling window is.
Yeah.
So how lean can you go and how rich can you go at any particular operating point. And that's why we control the tolerance on all of our parts to such a fine detail. And it actually comes as quite an expense on the production of the engine, but we need that because the fuel quality and composition that we're seeing in different regions is drastically different.
Okay.
It all makes it run differently.
Okay.
Right? It's not a factor in automotive because they have closed loop control, they have adaptive systems, but those systems don't work on a 2-stroke because of the oil and exhaust. Plus, the quick revving nature of a 2-stroke doesn't lend itself to use automotive technologies.
Okay. Have you ever developed or tried to make like a catalyst, like a catalyst converter on the snowmobile?
I'm sure that every manufacturer has tried that at one point,
Yeah.
Especially as the emission regulations were just coming into effect. Everyone evaluated it to some concept. The biggest challenge that you face with a catalyst on a 2-stroke is the amount of exhaust flow that you need necessitates a big catalyst or a highly porous catalyst, which will start to lose its effectivity. But the bigger impact of it is the increase in back pressure. So as that back pressure goes up, then your stability window on the engine starts to narrow. So you can only run a very narrow range of fueling settings.
Okay.
So that's the biggest challenge we face, and that's sort of what we did with the Patriot Boost, because like turbochargers also increase the back pressure. So that's why we have our wastegate on the tube pipe, so that we can control the pressure in the pipe better. And that's what allows the vehicle to accelerate.
Okay. So when did you start with the Boost project?
It started in various forms, probably around, I think it was 2012. We started experimenting with what turbochargers could do for our application. They were just starting to move from the fringes to be really more viable for a vehicle use case.
Yeah.
So there were definite benefits there, but there were challenges we needed to.
Yeah.
Right. So on a turbo, you face a number of challenges. One is the stability with the increasing pipe pressure. You face challenges on sound, and you also face challenges on emissions, because with that turbo comes increased fuel, and you start to lose some of your scavenging efficiency of the engine.
Okay. So approximately like 10 years before you released it.
Yep.
Okay.
Yeah, and it started. We tried all the concepts. We benchmarked all the aftermarket companies, and we learned where they worked really well and where their downfalls were, what we had to work on. So there were always opportunities to make it work, but it really took a breakthrough from our team operating on the dyno to find the aspect that worked well, which became the smart boost system, which is the wastegate in the tube pipe before the stinger.
But you had some kind of aha moment, didn't you?
Yeah, we actually we broke one of the exhaust springs. So as the boost pressure rises, the head pipe started to separate from the manifold, and all of a sudden we saw this huge increase in power. And that was because we were effectively dropping the pressure in the pipe. So once you understand that that was what was causing that power increase, we could go work to iterate through the different options for the wastegate placement to achieve that same effect. And then with that, like as you start doing active control of the wastegate and doing it through our ECU, we could develop a whole number of control strategies that improve the response and the stability of the wastegate to improve the boost response while still preserving the naturally aspirated part.
Yeah. So controlling the wastegate, that's the key part in one of the big things.
Yeah. Oh. That was a huge undertaking. Like we iterated through probably 120 different software versions and adding in functions that we thought we might need, because it's one thing to make one engine work.
Yeah.
It's one thing to make it work at one location, but you're talking that we need to make our vehicles work from sea level up to 12,000 feet of elevation with a number of different fuels and a number of different ambient temperatures. So it all becomes a factor. So you got to build in all of the logic that allows you to compensate for these without it being an entire process where you have to go and map every single characteristic. So we have a certain number of mapped components, and we have a certain number of feedback loop controls that operate within our turbo system.
Okay. But that specific wastegate that you can control with the ECU, you couldn't buy that at that time? Or did you have to manufacture it yourself and do the software yourself and everything? Or how did you do the first tryout with that controlled wastegate?
So we actually started with, we prototyped a wastegate with one company, and we built a boost control add-on box to work with our ECU.
Yeah, okay.
Right, that would control it based on a number of different parameters, right? And that allowed us to iterate quickly through and understand what functions we were going to need to be able to operate with. And then once that was done, we went to the actual hard design of the wastegate. It iterated through a couple different diameters, a couple different materials, a couple different placements.
Yeah.
And then we worked with our ECU supplier. We have a really good working relationship on the software side where we come up with a lot of the concepts, they do the coding, and it operates as a loop where we continually test, give feedback, they implement some potential solutions that we have ideas on.
Okay. Do you remember the first really successful dyno bowl with the new stuff? And it must have been a fun day to go to work. Just that day, this day we're going to try this new stuff.
Once we started to get all the real parts and we ran it,
Programmet presenteras av RG3 Suspension, Motorsnack, Svedea snöskoterförsäkringar, norrländsk skadehantering och Sveriges nöjdaste kunder 5 år i rad.
After that first aha moment, then we started to refer to the program as Patriot Plus. Right, it had a number of different names over the years. Our internal code name was Medusa.
The Medusa.
Medusa.
Oh, okay. So the boost is like the Medusa project.
Yeah. We have
top secret.
Well, we have a number. Yeah, we have code names for everything.
Ooh.
So that when we have internal communications, it doesn't list displacement.
Okay.
But once you start really running the concept, like the very first boost that we ran with the early parts of what would be our production solution was a very exciting time, because then it started to all come together, right? And then you're past the initial concept phase, right, where you prove that you could potentially do this. And then you got to get to the development phase where you have to work through all of the challenges that you need to overcome in the next couple of years.
But you seem to be a pretty smart guy, but you can always learn more in your line of work.
I think working on snowmobiles and working on two-strokes is a lifelong learning process. Yeah. We're always inventing and we're always developing new technologies, and we have a very experienced team in Roseau that have been around two-stroke for a very long time. Yeah. So there's always a lot that you can learn. And honestly, if you're not learning when you're working on two strokes, you should find something else to do.
Yeah, absolutely, yeah. Okay. But it must have been a really exciting time just with that boost project, the Medusa project. Yeah.
Yeah, and honestly, like the entire Patriot program, starting with 850, then 650, then boost, then 9R, has been a really exciting time at Polaris, because we came off the back of not having a whole lot of new engine programs. I mean, we had the 800 HO, but a lot of our engines were fundamentally the 800 and 600 that we had run for years.
Yeah.
So to go into it and do 4 new engines plus the 4-stroke in a snowmobile was a very exciting time, and there was a lot of work and there was a lot of challenges that we faced on it. And there's still a lot of learning that we're doing, but it was incredibly exciting and incredibly satisfying to see those vehicles hit the snow.
And the 4-stroke department, you're not involved in that, you're just 2-stroke?
Yeah, we have a separate group of people that work on the 4-stroke. Some of them are on the ORV, so focusing on Razor and Ranger lines that help out with some of the engine design aspect. The CAL is done by a different crew, split between Roseau and Wyoming. Wyoming is our other engine facility in Minnesota.
And you're located in Roseau?
I'm in Roseau.
Okay.
Yep.
So you're actually, we talked yesterday, you're actually almost Swedish.
Quarter Swedish.
Quarter Swedish.
On my mom's side.
Yeah, Hellström.
Hellström.
Yeah. Okay. That's really good. That's maybe one of the things that made a big part in the Boost project. I can imagine.
The Swedish influence.
Yes, I can imagine that. So, yeah. So, okay. And the 9R project, you were involved in that too?
Yep. The 9R started as racing. Right? We've been racing the 9R engine in various forms for years. And no one ever knew that it was out there.
And that's one of the things you do. You test the prototype parts in the field, racing.
Yeah.
Okay.
Yeah, the Boost ran in hill climb racing in the open class.
Yeah.
For years.
And no one
knew it was a production solution. Mm-hmm. We were using that as part of our validation. And then 9R was the same way.
Okay. Do the racer know it? The driver?
Yeah.
He knows.
Yeah. We typically do that racing with our athletes. So they're brought into the fold to understand what we're doing, and we work closely with them. Mm-hmm. Like when we did Medusa at Jackson Hole, there was probably a team of 5 or 6 Polaris engineers that were there supporting it and just learning everything that we could.
And you doing it under the radar, so.
Yep.
Okay. My God. Okay. So the 9R, how many years did you play around with all the different configurations?
The 9R didn't have as many iterations through the design as 850 did, because we knew that we had an architecture that we liked. So the idea on that was when we built the 850 Patriot, we knew that we wanted enough material in the cylinders and enough allowance in that architecture to be able to go all the way down to 650cc and all the way up to 899cc. Because 899 is the limit for hill climb racing. So that engine was designed from the start to have that level of allowance. So we started building the first 9Rs in 2019 or 2020.
Okay.
So generally, whenever something new releases, we're already working on the next one.
Okay. So the 9R engine, is that the same engine that they use in the, or is that a bit hotter engine that the racer use?
The racing usually uses a different calibration because they can run race gas.
Okay.
Yeah.
So compression, high compression, and
they're usually a little bit higher on compression. Production versions are a little bit lower, but fundamentally the architecture is mostly the same.
Okay.
Like we mostly use stock engines with just custom cals and some exhaust work that's done on them.
Okay.
But we do race that engine in the stock class and win.
Okay. And then like in the modified class, is it just one pipe or is it 2 pipes? Or?
We do have both configurations. Like 650s, we do run some twin pipe stuff. 9Rs, we've tended to stick to a single pipe, but there are some twin pipe versions running around.
Why isn't there any sleds with twin pipes from that you sell, like that you can buy?
The biggest challenge that you face with twin pipes is packaging. Right, the vehicles are getting smaller and smaller and smaller, and there's more and more components that have to go under the engine or under the bodywork. So the amount of room that you have to make a twin pipe setup and have all the geometry that you actually want for it to be successful, you don't really have that space.
Oh, okay.
Like, it is possible, but you got to remember that you also have to worry about thermal management and heat control, right? Because you don't want to be melting any components.
Okay. Will we ever see the triple again? 3 cylinders? Is that engine total, the hype, like in Sweden? If you should, like 10 years ago, you can buy a Thundercat 1000 for like $1,500. Now it's $10,000. So it's really hype about triples. Do you think we're ever going to see a triple again?
So, as always, you know this, I can't talk about any future stuff, but triples do present a challenge. The twin pipe setup gets 50% worse on a triple because you need a triple to make the performance that people want.
And the gains with a twin pipe solution, is it worth it, or is it like?
It depends what you're doing. Like, if you want all around riding and you want to ride through the trees and you want to ride single track stuff and you just want a highly versatile engine, twin pipe doesn't get you that.
No.
Now, if you want to go racing and you want to do hill climb or you want to do drag racing, there's a benefit there.
Yeah.
Twin pipes tend to be a little bit more temperamental and tend to run. They run better at wide open. At the sacrifice of some of the low speed performance.
Oh, okay. So, but we're not shutting the door for the triple. We can hope in a way. So I ask everybody about this because we want to see the triple back again. So.
I know everybody has a fondness for the triple.
Yeah.
I won't deny that they sound amazing.
Yeah.
And with a good running triple, they actually run really well.
Yeah.
There are just challenges. Right,
yeah.
The weight increases, the packaging becomes a challenge, especially in modern vehicles. So,
but if you should get the order, fix a triple now, you should do that with happiness and enjoy, shouldn't you?
I built a number of triples over the years, and it's always fun. It's always enjoyable. It would have to be a significant rethink on the architecture and the path that we're going down.
Yeah. Like some kind of V engine or something, a V3 or something. Honda had it in the 80s and 90s with the MotoGP racing and won everything with it. So.
They did, and there's been V3, there's been V4. Now V3 and V4 don't quite sound the same as a 120-degree inline triple. I think that's what a lot of people are ultimately clamoring for is the sound.
Absolutely. I didn't even think about that, so okay. Okay, thank you. Amazing to talk to you. You're great knowledge about two-stroke and probably other stuff too because you're Swedish. So we usually know as everything.
Just the universal knowledge. Right?
Yes, of course. I say thank you to you and good luck in the future.
Thank you.
Thank you.
Programmet presenteras av RG3 Suspension, Motorsnack, Svedea snöskoterförsäkringar, norrländsk skadehantering och Sveriges nöjdaste kunder 5 år i rad.